Now that we can do implicit differentiation for a first derivative, now we want to take it a step further with a second derivative. One thing to keep in mind with the second derivative is dy dx is often going to appear. Remember, dy dx stands for the first derivative, so we're going to oftentimes substitute with the first value we find. So I'm going to go ahead and jump right into this first problem here. I'm asked to find the second derivative. So as with second derivatives in the past, I'm going to first find the first derivative, and again I have to use implicit differentiation since y is not by itself. So x squared becomes 2x, y squared becomes 2y using the power rule on both of those. But because y is my dependent variable, I have to go ahead and tack on dy dx. The derivative of 25 is just 0. I'm going to go ahead and get dy dx by itself by subtracting 2x and dividing by 2y. I'm going to do it in one step, and I get dy dx is negative 2x over 2y, which reduces to just be negative x over y. Now that I found my first derivative, I'm going to go ahead and switch colors and find my second derivative. So I see I have to use the quotient rule because I have division here. So I'm going to set up my quotient rule and find my first function is negative x. The derivative of that is negative 1. My second function is y. The derivative of that, it being dependent, is dy dx. And so now my second derivative, which notation looks like this, is going to be the derivative of the first times the second, so negative 1 times y is negative y, quotient rule, so minus the second times the first, so negative x dy dx. So minus a negative x is going to become plus x dy dx, all over my second function squared. So from here, I'm going to go ahead and I'm going to replace dy dx with the negative x over y. So I'm going to put this in for dy dx. I'm also going to go ahead and say, instead of dividing the whole thing by y squared, I'm going to multiply the whole thing by 1 over y squared. Then I don't have the double fraction. And again, then this all gets multiplied by 1 over y squared. Now from here, I can go ahead and distribute the 1 over y squared in and also multiply my x's, giving me negative y over y squared minus x squared over y cubed. If I multiplied top and bottom of that first fraction by a y, I realize I would have a common denominator and I could write it together. So I'm going to go ahead and do that, giving me negative y squared minus x squared all over y cubed. So oftentimes I'm done at this point, but I just happen to notice that I've seen almost this exact expression already in this problem, except I saw that x squared plus y squared was 25. So if I factor a negative out of here, I'll have y squared plus x squared, and I can substitute that with 25. So I'm going to go ahead and do that, giving me negative 1 times y squared plus x squared all over y cubed. And then, as I said just a moment ago, replacing y squared with x squared with this here with 25 gives me negative 25 over y cubed for my second derivative. Again, a long problem, a lot of steps to take care of, but notice it's just using the same differentiation rules that we've already learned. So just make sure you're following through your steps and really taking notice of positives, negatives, things like that, so you're not making those little errors. And let's go ahead and look at letter B. So again, I'm doing the same process. So I first find my first derivative. So I'm going to go ahead and do both sides. So 2y dy dx equals 9x squared minus 2. So my dy dx, so my first derivative, is 9x squared minus 2 all over 2y. So now once again, in order to find my second derivative, I'm going to go ahead and need to use the quotient rule. So my first function is 9x squared minus 2. The derivative of that is 18x, and my second function is 2y. The derivative of that would be 2 dy dx. And then going ahead to follow my quotient rule, I can say that my second derivative is equal to the derivative of the first times the second, so 18x times 2y is 36xy, minus the second times the first, So it doesn't matter what order I multiply in, so I'm going to go ahead and say that that gives me minus 2 times 9x squared minus 2 dy dx. Well, just like we saw a moment ago, I want to replace that dy dx with this here, but before I do, I almost forgot. It's the quotient rule, so I have to say all over my second squared. So 2y squared would be 4y squared. So now I'm going to go ahead and replace my dy dx with this expression here. And I notice that when I do, I'm going to end up with 9x squared minus 2 times 9x squared minus 2. So that's going to become 9x squared minus 2 squared. But I will write that step in. So now I have 36xy minus 2 times 9x squared minus 2 times 9x squared minus 2 all over 2y. Well, not only can I say that these are the same and say write it once and square it, I can also cancel out these 2's. So doing that, and that is still all over, I'm going to keep forgetting this, 4y squared, hopefully you're not, I get 36xy minus 9x squared minus 2 squared. This is now just over a y, and the whole thing is over 4y squared. So just like before, I'm going to say this whole thing is being multiplied by 1 over 4y squared, and then I can distribute it in. Doing that is my next step. I get 36xy over 4y squared minus 9x squared minus 2 squared all over 4y cubed. From here, I notice I could get a common denominator if I wanted to, and then I could put them together. The only thing I would need for a common denominator is to multiply this function here, or this, fraction, this term here, top and bottom by a y. So I'm going to go ahead and do that. And I'm going to say that my final answer for my second derivative is equal to 36xy squared minus 9x squared minus 2 squared all over 4y cubed. And I know I could write this twice, or I could FOIL this out, but notice that even if I were to FOIL this, it's not going to be a like term because there's no y's involved with this anyway, so nothing's going to combine, so I'm going to go ahead and stop there. So just a quick recap at the end of this video. Big thing is to find a second derivative, we are just taking the first derivative and finding the derivative of that. Don't forget that if dy dx appears, we want to replace that with what we found for the first derivative. And just again, being careful and really watching your steps, because there are a lot of them, and we oftentimes are going to involve a quotient rule or a product rule when we're finding that second derivative.